Hello, this is Math Kimchi, and today I will be talking about summation. So, the general notation for summation goes something like this. Uh, what you see here is the Greek letter sigma, and in math, it means summation. And you can see there's a bunch of variables here, and uh, what all the variables mean is I doesn't actually mean I as in the square root of -1. It's just a variable. But n and m are supposed to be constants, and m is less than n, and they're usually both integers. And in here, x of I, x is kind of like a sequence, or it could be x of I is usually just going to be some type of expression. And what this is equal to is x of m plus x of m plus 1, and you keep adding 1 until you get to x of n, and you include both m and nth terms of x. And this might seem kind of weird with m and n and x of I just being unknowns. So let's have an example. So an example is the sum of this, and we have I starting out at 1 and we stop at 4, and our x of I is going to be 2 times I, and this is equal to 2 times the first I, which is 1, and then we add I by 1, so we get I is 2, and we have 2 times 2 plus 2 times 3 plus 2 times 4, and once we hit I equals 5, we stop, so we stop at 2 times 5, and that just turns into 30. And another example would be I equals 4, and it stops at 7, and the expression here is I squared minus 5, and that's just going to be 4 squared minus 5, and I becomes 5, then 6, and we stop when we have 7 squared minus 5, and that just turns into 106. So now let's look at summations and sequences. So one way people use summations in with arithmetic sequences, and we see that AI is the thing that's being added, and AI is just the ith term of an arithmetic sequence in our case. And another way to write this down is like this, and this is actually supposed to be an I instead of an N, and A1 and D are gonna change depending on the arithmetic sequence. So if we kind of write down what this means, it means A1 plus N minus 1D, and this is the nth term, and then this is this is the n plus 1th term, and that keeps on going until we have the m minus 1th term, and finally the last term, which is the mth term of a. And we can see that we're just using the formula for arithmetic sequences. And one thing we can do is multiply everything by 2. So as you can see here, and we'll just be adding this by itself, and we can rearrange this to be backwards, and this is what we get when we flip this around. And let's just put it back up there. And now we can factor out everything. So we can factor out a1, and we know that there's going to be 2 times however many terms there are, because in every single term there's one a1, and there's 2 times however many terms there are originally, because we multiplied everything by 2. And we can also just factor the d out once we take out the a1s. And I'm using t for the number of terms from n to m. And we can also factor out the negative ones. So this one, this one, this one, this one, and this one, and you get the point. And we are going to have 2t times negative 1, because there is going to be a minus 1 every single term, and there's twice as many terms. And we can distribute the d onto negative 2t, and again say everything is equal to, or this is equal to 2t a1 minus 2t times d, and then this whole thing times d. And now we can add these two, and we keep on doing that until we get these 2 plus these 2. And we know that there's going to be an equal amount of things we're going to add both here and here, because they're literally the same thing, just rearranged. And when we add this, we get n plus m plus n plus 1 plus m minus 1, and then that keeps on going until we have m minus 1 plus n plus 1, and then n plus m, and we multiply all that by d. And we see that that's just equal to n plus m, because all the constants cancel out. So the third thing here is going to be n plus 2 plus m minus 2, and the number is just going to be the same over and over again. And so now we know that there's going to be t number of n plus m's in here. And it's not 2t, because when we added this all up, we got rid of all the terms, or like we halved the amount of additions we're doing by adding everything up. And so we know that there's t times n plus m in here. So we have the 2 times the sum of ai when I goes from n to m is equal to 2t of a1 minus 2t times d plus n plus m times 2d, or td. And we can factor out the t, and t stands for, or the way we can get t is by doing m minus n, but then we have to add a 1, because if we just did m minus n, it would be if one of these were included but not the other one, but we know that both n and m are included when we go from n to m. So that's why the plus 1 is there. And yeah, we can divide everything out by 2 to get what we had originally. And we can distribute the d, and another way of writing just this is a1 minus d plus dn plus a1 minus d plus dm. And if you know where I'm going with this, that is going to be a1 of plus n minus 1d plus a1 plus m minus 1d. And we actually see that this is just the nth term of a, and this is the mth term of a. So we get this, and another way of writing this is just the number of terms times the starting term plus the ending term divided by 2. So basically what this is saying is the average of the first, not the first, but the starting and ending terms. So this entire thing, an plus am divided by 2, is just going to be the average, and we just multiply the average by however many terms there are, and we can kind of see why that works, and we can also prove it using just algebra. And that's it for part 1 of summations, and in the next video I'll be talking about geometric sequences and the summations of geometric sequences, and if I can, it would be good to also create a program that finds summations of arithmetic and geometric sequences by not just using the formula, but kind of looking at how we would do it without the formula. But that's it for this video, and thanks for watching.